Hello everybody, my name is Barbara and I would like to welcome you all to our latest Knowledge webinar episode. In this week's episode, enjoy a Pocket Vectorworks project. This demonstration of a tiny structure modeled and documented in Vectorworks 2016 uses many objects and techniques found in much larger projects like walls, roofs, and floors. Importing SketchUp models and cleaning them up, developing detailed framing models using the automated wall and roof framer modules, customizing the structural model, and annotating drawings with viewports and callouts. Today's presenter is Texas architect Francois Levy. Francois holds degrees in architecture and architectural engineering from University of Texas Austin, where he taught, as well as the University of Texas San Antonio. His projects have attracted national press, including Dwell Magazine and HGTV. He's also author of BIM in Small Scale Sustainable Design, contributor to the Architect's Handbook of Professional Practice, and he's also lectured widely on sustainability, BIM, and space architecture, on which he has presented at international conferences. To show you a little bit about what M.Arch does, is an overview. This is a sample of our product page, and M.Arch is one of the largest online stores for design software, and we offer a huge assortment of software solutions that cater to virtually every designer's needs. So come visit our page at M.Arch.com, and for more daily software news and limited time promotions, also pay visit to the M.Arch blog and follow us on Google+, Facebook, and Twitter. Coming up next week, collaborating in a BIM world with Bluebeam Review. Last but not least, today's webinar is free and is being recorded. So if you want to rewatch this or any other webinar episode in our collection, just head on over to M.Arch's YouTube or Vimeo channels. And now it's time for me to stop talking and pass the screen to Francois. Here we go, Francois. Take it away.
Thank you, Barbara. Thanks for the great introduction, and I really appreciate everyone coming to check out this webinar today. There's actually quite a lot to talk about for such a tiny project. You might not think it, so I would encourage everyone viewing this to take advantage of the recording after the fact, maybe go back and watch it again and catch up on some spots where maybe I went a little too quickly in order to be able to cover everything. And of course, I certainly welcome anyone emailing me and contacting me after this webinar if you have any comments or questions. And finally, a small little housekeeping note. I'm going to be using a little presentation tool called Mouse Pose. That's what's showing you this little spotlight, and so that you can better see what I'm doing. And if that just gets to be overwhelmingly distracting, Barbara, please let me know, and I will turn it off. So this little project here is a small shed that I designed as a kind of a prototype, just as a storage shed for a client. And you can see that it's has a simple shed roof. There's a floor structure that I've modeled. There's some content there, some for the shed, a door, a window, a roof, and a floor structure. And so it occurred to me that this would be a great opportunity to talk about some of these features and to also see how all of these things can be modeled together and documented in Vectorworks. So the first thing that I want to show you are the various walls, because these are Vectorworks walls using some of the new wall style features. So in this file, again, we've these four walls. You'll notice there's a couple of things that are happening here. One is that the wall cladding has a texture to it. I'm rendering this in OpenGL so that it renders quickly. So that's kind of interesting. If we go to a hidden line view, you'll be able to see in a moment that not only does that wall have an OpenGL texture, but it has a 3D hatch that's being applied to it in an automated fashion. A little more on that later. Also, the wall is interacting with the roof in an interesting way. So over on the north side of the shed here, I have the siding running all the way up and covering up the fascia so that the siding just dies right into the roofing material. So in the old days, that would have had to have been a rather complex modeling process, but I'll show you how the roof components and the wall components work together to make these kinds of custom conditions possible. So over here we've got one overhang on one side, a longer overhang on the other, and then on the back, no overhang with the siding going right up to the decking. So let's take a look at that wall. Over here in the resource browser, you can see that I have a variety of resources in this file, and I'll close some of them. And I have a wall style. So let's take a look at that. I'm just going to right-click on it. When I left-click, you get a little red dot. When I right-click, you get a little green dot. So if I right-click on that wall and edit it, you can see that this is a styled wall. So that's something that you can save in Vectorworks Architect, your wall styles. In Vectorworks Fundamentals, you can still have walls with components. You just can't save them as styles. So they're a little bit less powerful, but still pretty usable, certainly. And so I've added components to this wall. So I have a structural components, the 2x4 studs, which are assigned to one class. And then I have the structural sheathing, which is a 1/2 inch, and then the structural siding, which is also nominally 1/2 inch. And so each of these is assigned to a separate class, and I can customize that all that I want. So let's look at the 2x4 stud component. So it's given a name, and I've assigned a class to it from the definition, and then an overall thickness. And then notice that the component top is defined as being relative to the wall. In other words, this stud will follow the overall wall height, this component, and it'll follow those wall peaks. And the offset is 0, so it follows it exactly. It's neither above or below the top of the wall shape. Likewise, the bottom has an offset of 0. So let me cancel out here and look at the siding, and you'll see that that's a little bit different. If I look at the siding here, it has a distinct class, and I've given it an offset of 5.5 inches. So no matter what the wall height is, the siding is going to extend 5.5 inches above it, and so that's so that it will extend to cover the 2x6 roof. And then the bottom offset is a couple of inches. So I can change that from -2 to -1, for example. And then when I do that, you'll see that there's a little bit less of an offset. So let me do that one more time so everybody can see a little bit more clearly. In fact, I'll go ahead and exaggerate it and make it something rather absurd. So you see how that wall siding extends a foot below the bottom of the wall. So in this, typically what I would do is I would let that siding overhang by 1 inch or 2 for moisture control. That's how I can achieve that. So let me back up a little bit. Oops, sorry. There we go. It's my walkthrough tool that I wanted. This is the problem with having custom workspaces, is sometimes the normal tools aren't where you expect them to be in a customized setting. So I'm going to use the visibility tool here to make my roof gray so that it's ghosted in, but you can still see it. So you can see how the wall has intelligently conformed to the roof geometry. On these two sides, the wall siding is extending to cover up the roof, and over here, that siding is not, it's not just digging into the roof and being obscured by it. It literally isn't there, and we'll see in a moment why that is. And so that's important because if I have a, I mean, it's probably not important for the model to be utterly faithful in this case, but on a much larger project, you can imagine where if I had these sort of modeling inaccuracies and I was doing a takeoff, for example, to try to calculate the amount of siding material, having these modeling discrepancies might, over a large project, create some inaccuracies. So let me go back and just point out a couple more things about this wall style. That I have a texture that is applied to the wall style, and so I have some options. I can either apply individual textures to individual components, or I can apply texture to the wall overall. And in this case, the wall attributes, the texture is going to follow. Let me click on the wall and we'll look at the object info palette. So it's in the wall exterior frame class, and then over on the render side, you can see that the left side, which in the world of Vectorworks, tends to be the outside for an exterior wall. The left side has a texture applied to it by class, and so if I change that class definition, let's say we'll go crazy, I'll give it a metal U-panel texture. If I do that, then Vectorworks will automatically change the texture on the wall. I don't have to alter the wall definition. So I can make textures either by component or by individual components for the wall, or by overall texture. And since here I really only have one texture, it's fine for me to go ahead and assign that to the overall. So let me now talk about roof, because having shown you the wall style, let's look at the roof style. I'll go ahead and make that roof visible. By making its class visible with the visibility tool. So a newer development in Vectorworks is the introduction of roof styles like wall styles. So I've got one here for a 2x6 metal roof, and let's go ahead and look at that and see that it's very similar, right? The dialog box here is very similar to the wall style dialog box. I have components. I can assign individual components to those components. One thing that I have in a wall style is I can define which of these components is going to be the core. Usually that's the structure of the wall, but doesn't necessarily have to be. And the core helps Vectorworks, defining the core helps Vectorworks make more intelligent decisions about how to auto-join walls. Well, with roof styles, I don't have a structural core, but I do have a datum. So when I'm creating a roof, the datum will define which of these different thicknesses and components are going to control what the roof's Z coordinate is in space. So it can be either the top or the bottom of any one of these components. And then you can see that as with the wall, I can define a thickness and assign a class, right? But then the interesting thing about these components are these edge conditions. So the framing component here, which is sort of the main thickness of the roof, not differentiated, but just a 5.5-inch swath through the roof, it's bound by the roof edge. So whatever polygon I used for the roof when I first drew it or created it, that component is going to go right up to the edge. And you notice that its modification is it either has no modification of any associated walls, or it clips the walls, or is clipped by the walls. So this is going to clip any walls that are associated with it, just this component. And then it's going to be pulled back from that roof edge by 2 inches. So just like the siding component dipped below the floor elevation by an inch or two, here the roof is going to be pulled back from the edge by a couple of inches. So notice that the roofing itself, the thickness that represents the metal roofing, has it clips the walls and it goes right to the roof edge. The decking, which is just a plywood sheathing or OSB, it's bound by the roof edge. It's negative ½ an inch from that edge. And so that's what's giving me this visible overhang where I've got the roof here, the roof component, and then the decking, and then the framing component. Now if we kind of peek under this roof, you can see that I've got one material which represents the ceiling inside that space here, and then another material which represents the soffit. So if I edit that, you can see that the vaulted ceiling is being clipped by the wall. So whenever it encounters a wall that is linked to that roof, it is going to be clipped back. And so now if I use my visibility tool, right here, and make my walls grayed out, you can see how the walls are clipping certain components of that roof. And then to get the separate overhangs of the roof, I simply can click on each of the roof edge settings for that edge of the roof, and here I defined a 16-inch overhang. On this side I have a 3-foot overhang. On this edge I have a 2-inch overhang, and on that edge I have a 2-inch overhang. So I can control the overhang on each of the faces, and so that's giving me a really detailed model of the roof and the walls as they interact. And then you can see that if I have that roof selected in the Object Info palette, you can see that under wall clipping it is being clipped by 4 walls. So I can disassociate all the walls, and you can see that now the roof is changing. That ceiling material is running all the way out to the edge because it's no longer associated with any walls. But if I pick some walls to associate, I'll need to make those walls visible in order to associate them. All right, so if I pick some walls to associate, then I can click on this wall and that wall, maybe use my zoom loop to be able to see through the model in wireframe mode, and select all 4 walls and then hit this little checkbox, and then you can see that the roof reshapes in order to reflect the association that it's got. So I've got walls and roofs that are interacting together in Vectorworks really nicely in order to give me the model that I want without having to do a lot of custom modeling. Over here I'm going to talk briefly about this window as a kind of a stand-in for the windows and doors. Let me back up a little bit and just show you some of the settings that I've got for this window. So it's a horizontal slider, and it can operate with both sashes, or I could just have one sash operate. And for 2D visualization, I could control the line weights of all of the different components, the jam, sash, trim, and so forth. Under 3D, I can show an interior and an exterior marker. And here I've got those markers shown in a class that's turned off. But if I go to my navigation palette and turn on that class, here we go. So you can see that here that marker is showing up. So I'll want that turned on in my elevations so that I can see how the window is operating. Now, in this case, I'm using this window to model an anodized aluminum window with a black or nearly black finish. But let's say that I wanted to do something else. Let's say that I wanted to show a vinyl window with a colored exterior finish. So I've got a classes tab over here. So you can see that I've got different classes for all of the 3D components of the window that are available. So here for the interior sash, I'm going to create on the fly a new class. Okay, and I'll make it visible in all of my viewports and save views. And I'll just make it sort of an off-white color. And so for the interior sash and interior jamb, I'll use that material. I don't have any interior trim, so I don't need to do that. And so you can see that I've got this window that is this off-white color on the interior condition, but on the exterior it maintains that window class. So I've got a lot of customizing options with windows. Likewise with doors, where I can assign hardware, kick plates. Don't really have time in such a short presentation to go through all of the options, but you can see if I just double click on the door that I've got a lot of hardware options. I can assign kick plates, give the leaf some vision panels, for example, and the bottom edge offset, for example, could be 6 feet, not 6 inches, or 5 feet. That's probably too much, right? There we go. And on my 3D view, I could not show the door open, so that'll close the door for me. So a lot of different options for how I might want to represent all of those objects. So you'll notice that in my view here, in one of my, I've got, let's see, do I have those? I don't. Let's look at another file here. There we go. So over here, in another variation, you can see that I've got these models of scooters and motorcycles and kayaks. So kayaks are not, it's important for the client to fit his kayaks in this shed, but that's not really something that I typically model. And you can see that there's a fair amount of detail to that kayak, right? Probably would have taken me a while to sit down and model all of that, and it would have been an investment in time for something that I would only use once in a very great while. So I went to the 3D Warehouse Sketchup site, which most of you are probably very familiar with. And from there, I downloaded some models. And let's see, so I can find it more easily. So typically when I download these models, I'm going to go ahead and import them right into a blank document and clean them up before I do much with it. So from my file menu, I'll go ahead and import a SketchUp model. So there's import SketchUp, and just go to my desktop, and there it is as an SKP file. I'll open that up. So you can see that when I import SketchUp models, I've got a couple of different import methods available to me, either as a 3D polygon and mesh or as an architectural object. So if I were importing a model of a house or some sort of an architectural structure, I would choose architectural objects, and then any vertical face would get translated as a Vectorworks wall, horizontals as slabs, and sloped faces would be roof faces. But that's not the case here. It's just a 3D mesh polygon. And so under my options, I can create RenderWorks textures for all the materials or not, import transparency and image data, bring them in as mesh objects or polygons, and then for architectural objects, which is not the case here, I can define as default wall, roof, and floor thickness. So I'll go ahead and bring that in. And so there's my kayak, right? So very, very straightforward. Generally, you might want to check on the scale and fidelity of the model, make sure that everything is okay. One of the great things about the 3D warehouse is there are a lot of models to choose from, and then a problem is that sometimes the models vary in quality since they're all user submitted. And so I may want to clean up the various classes that are in this model. I may want to delete things that I don't really need. So these paddles, for example, probably not important for me to have in the model. But then you'll notice that if I look at some of the 3D geometry here, let's look at this bracket. Look at it in wireframe and turn off my other options. So there's quite a lot of faceting, and this is actually not too bad of an example. But in some cases you get just a whole lot of faceting, and so it may seem innocent enough with just one bracket, but if I had a bunch of these, then I may spend a lot of extra time rendering them. So let me show you how I dealt with that. So once I cleaned this up, I segregated this into two separate symbols. I've got the kayak itself as a single symbol. It was really needed to demonstrate to the client that these objects would fit. But then the bracket is more of an architectural fixture that I want to show up in various architectural drawings. So I made that its own symbol. And you can see that the symbol itself contains a Vectorworks object called an auto-hybrid, which is a very interesting kind of object. So you can create auto-hybrids from the AEC menu, create auto-hybrid. And what Vectorworks does is it takes 3D geometry like this complex bracket, and it projects in plan what that 3D geometry would look like in a 2D plan projection. So I can display it as an auto-hybrid as 2D only or as 2D and 3D. And then for the 2D appearances, I can specify what the attributes are of the object along a cut plane, below the cut plane, and above the cut plane. In this case, I don't really want the object to be shown in plan sections, so I just set a cut plane that's quite high. And below the cut plane, I had it display with the class attributes of whatever objects are contained within that geometry. And above the cut plane, I chose not to show anything, but I could show a dashed structure, for example. So, and then if I edit that auto-hybrid, you can see the 3D geometry that I created. So the tubing is a shell. So you can see I got a little carried away and even showed that tube as hollow. Right? So that's a shell. And if I ungroup the shell, you can see that it's a solid addition. So I'm burrowing down, and so I have an extrude along path here, an extrude along path there, and by the way, I could change the path of each of those objects or change the profile. So I could change the diameter here to say something absurd, like 4 inches, and then I would get this kind of rather silly looking bracket. So I can edit things along the way, and so what that means is that instead of having to keep track of lots of different facets, Vectorworks just has to keep track of the profile and the path, And you can see in wireframe that it just has fewer computational points to keep track of. So the result is I get a smoother model, but I also get one that renders a little faster. Oh, and now poor Vectorworks is having to recalculate that auto hybrid since I edited it. So we'll give that a moment, and let me see if I've got any burning questions. Barbara, any questions so far?
Yes, there's a couple of questions. Let's go in order. Oh, sorry. Hello, can you hear me?
Yes.
Okay.
I can hear you.
I'm going in order of when they got here. Okay.
Sure.
How do you handle extending the cladding when it is different on first floor and second floor? Will these be two wall types?
Yeah, generally I would have two separate wall styles for the ground floor and the upper floor.
Fantastic. Okay.
Yeah.
Can you do exposed framing rafter tails rather than solid framing?
Yeah, we're going to get to that in just a minute.
Okay, perfect.
All right. Well, I'm back. So.
Okay, great. Perfect.
All right. So yeah, that's a great segue to the wall framer. So let me go back to. I'm going to revert to save because I don't want to break this file. Yes. Okay, so let's talk about the framing. So in this case, I've got some viewports on one sheet where I show sort of the architectural model with some annotations. But then if we look at the other sheet, you'll see that I have a framing model, right? So I have two different layers in this model, and the framing views are being populated by the framing layer, and the architectural views are being populated by the architectural model. So to get to that framing, what I would have done is, let's see, let me, no, this is fine. So under the AEC menu, I have a framing command, and when I select wall framer, I can give that model a new name, so I'll just call it frame, rather unimaginative. And then if I have multiple layers in my document, I can specify which layer or layers get framed. And I can choose to either have a 3D model output or a 2D model, which is to say drawings, basically elevations of each of the framing panel, or worksheets, any one or all of those. And then for options, I would specify the wall class, which is being framed. So if I have walls in an interior walls and exterior walls, I might want to frame the exterior walls only, not the interior walls, vice versa. I might have some concrete block walls or cast-in-place concrete walls that I obviously wouldn't want Vectorworks to frame for me. So I'm going to specify which classes get framed, and then you can see that I have a variety of settings which show, Vectorworks will customize the model with. So I don't want a double top plate or a bottom plate. I do want fire blocking. So I'll hit OK, and then I'll hit OK. And this won't take long. You can see that Vectorworks has now created 3 new layers. Before, my document only had 1 layer. So let's go to my layer options and show active only. So and then I've got some new classes that Vectorworks created for me. So here is my framing model, just based on those walls. And so Vectorworks applied certain rules, and it created a header of a certain size where my based on the opening of that window or that door. It gave me a single sole plate, it gave me a slope top plate, it gave me blocking and so forth. So most of those objects are meshes and extrusions. And then Vectorworks gave me some 2D elevations. So it went ahead and drew elevations of all 4 of those walls with some dimensioning. It gave me a plan diagram, 1, 2, 3, 4, where those are labeled in. And then Vectorworks also gave me a couple of worksheets where it listed the various panels, frame 1, 2, 3, and 4 in this case, and the length of the studs and what their cuts were and so forth. So I could use that as a bill of materials. And so it did all of that very, very quickly, obviously, and it would take a little longer for a larger project, but it's still kind of stunning. So let me take you over to the framing layer. So this is what that looks like after I've sort of played with it. I'll just go active only here, right? So you can see that just for fun, I've assigned some textures to it. Now I wanted to do some advanced framing, and so in some cases I've replaced a couple of, by hand modified some conditions. So I removed an extra stud to give myself a 2-stud corner here, and have just adjusted the model accordingly, right? And you can see that the roof is also framed, so let's go back and look at that. So from my perspective view, I can also, under the framing model, I can actually do this from any view, not just a perspective view. There is a roof framer module. And so from the selected roof, I can specify what the various framing components would be. In this case, I just really wanted rafters. All right, so I can create some rafters and or collars, plates, purlins, ridges, headers, whatever. So in this case, I wanted some rafters, and I'm going to specify some rafter sizes. And if I don't like the list of sizes that I get, I can go ahead and edit the list and add some more sizes and specify the minimum spacing, what the rafter position is relative to the bottom or the top of the selected roof component. I'll give it a class, so how about structural beam wood? Okay. And so Vectorworks has, let me group that. So Vectorworks has created these rafters for me. So in answer to the question, I could start by conceptually modeling a roof without exposed rafter tails, right? And then I could go back and have Vectorworks modify or convert that roof into a series of framing members to do exposed or expressed rafter tails. So in this case, I sort of played with the direction of some of these rafter objects. In fact, created a sort of structural fascia for this double cantilever, right? Simply by taking the objects that Vectorworks created for me and then modifying them. So I used the automated command to get me started, and then I moved on from there. So briefly, let me show you what that looks like. So unlike the wall, if I look at this wall, each of these objects is just a mesh or just an extrusion. So they're just simple 3D geometry. With the roof framer, it's a little more interesting. You can see that each one of these objects, these roof framing objects, are called a framing member. So they're parametric object, a plugin object. And so I can specify the span, and Vectorworks will calculate the overall length. So the span is the projection in plan. I can give it a width and a height, make it a solid beam or a rafter, any number of object types. Vectorworks will calculate the volume for me if I care about that. Now, if I'm using the framer to frame a concrete system, for example, I might be very concerned with what the volume of that would be. I can give it a specified pitch. I can roll it, I can miter it at the beginning or the end, I can bevel it, and so there's a tremendous amount of customization that I can perform, and then of course I can give this a class render, so if it's an exposed member where I care what the rendering attribute is, I can go ahead and show that as well. So the roof framer is actually a little more sophisticated than the wall framer because it gives me these kinds of objects. So here I just turn those rafters the other way rather than having them run the length of the slope in order to do this double cantilever. And you can see that I rolled it, the rafter by about 7 degrees so that we could sort of see it there. Give it a roll angle of 7.12 negative, right? So you can see how that is being controlled. And here we're in a perspective view, so that's why you're seeing it that way. So even from sort of a beginning concept of just a simple slab of a roof, I can have a more complicated roof structure taken from there. So once I've gotten this model developed, in this case I've got my framing model. Over here, and my architectural model over there, right? Once I've developed all of that, I can start to develop my documentation. So in this case, I have a sheet layer. So all of my modeling has happened on design layers, but now I've got a sheet layer. And so I've created this viewport on the sheet layer, and it's just a plan viewport. And you can see that because I've taken the trouble to lay out where all those studs are going to be, I'm actually showing those in plan. So if I look at the design layers that populate that viewport, both the framing, that is to say the structural and the architectural layers are populating that. And then I'm controlling which classes show up. So I'm going to show, for example, the framing stud class, right? But I'm not going to show the sill or the header or the block. I don't really want to see those. Likewise, I can even override classes. So for example, the roof class is being shown gray, but I'm also overriding its attributes so that it's a dashed line instead of a solid line. And then I can, within that viewport, I can go to an annotation space and I can drop in some dimensions for the overhang, for example, on each side. On the actual project, I adjusted the window location based on the number of studs. So here I dimensioned the location of the window as a function of the stud location, coordinated that. And then within that annotation, I also have these callouts. So those are notes that refer back to a database, an XML file, so that I only have to type my note once, and then I can just place it on the drawing either as a callout, as a keynote, or I can place the full text. In this case, I want it to be as a keynote. And then those callouts or keynotes populate a legend. And here I've got a note to refer to the other sheet for layout purposes. So here are all the notes for the project, and they're all consolidated. And then to generate these sections, I just took a section viewport through one of these plans. And so you can see that if I take the, let's say I take that section line, it is actually coordinated and linked to the viewport, the section viewport that it generates. So if I take that section viewport here and, for example, I reverse its direction, that'll mess up my dimensions, but you'll see. And you can see that when I did that, the key in the plan switched the other way. So reverse the direction again, see how it reversed over here, and then I can just update that viewport. So between plan viewports and section viewports and these perspectives, I can generate a variety of different views. Likewise, for my architectural sheet, I've got these elevations, and those are just section viewports that miss the model and that are keyed to it. So you'll notice that I've got some surface hatching. So for example, the roofing hatch shows up in the elevation where I can see the shed foreshortened, and then the 4x8 panel construction or siding with the express seam is shown here on these walls. So let me go back to my, architectural model. Maybe even go to a save view. There we go. So as I showed you earlier, I've got this little bit of a lo-fi sort of OpenGL rendering with this tile pattern here on the wall. If we look at the render tab of that wall, you can see that the left side, that is to say the outside of the wall, has this class texture. So I can find that texture in the resource browser under my Renderworks texture. There it is, my express seam texture. So let me show you what that looks like. So I can, there it is. I've got a lot more textures in this model. There it is. Let me edit that. So you can see that I've got essentially a modified brick shader with just a very, very thin grout line in order to show this express seam. It doesn't look so great on such a small surface, but on a larger wall it's a little more convincing. And then I also have a surface hatch applied to it. So let me edit the surface hatch. So Vectorworks is taking just a 2D hatch pattern, this express seam 8 foot by 4 foot, and it's superimposing it over the Renderworks texture so that when I'm in a render mode, see if I can dare to do an update of that rendering. Turn off a couple of classes here. I'll do a custom Renderworks rendering. Or let's do a fast Renderworks. So you can see with the fast Renderworks, it's pretty grainy, but you can see that I've got these express seams. If I do a final quality Renderworks, it'll look quite a bit better. Takes a little longer to render, but you get the idea. So Vectorworks is taking a hatch pattern, that is to say a 2D line pattern, and it's superimposing it on top of this rendering. So let's look at our hatches. And there it is. So I've associated this hatch pattern, which is just a series of lines of a very thin line weight. It's composed of 4 different line rules, if you will. So I'll zoom out and you can see how that works. So one is 8 feet long and it's about 7'11". It's 8 feet repeated, but there's a 1-inch gap at the very end. Right, so I get this little gap. I could just do a simple grid of a single line, but I wanted to show a little more detail since these are large scale. And so I've got these different lines which compose this hatch, and I can just, there's a ton of hatches out there in the wild that I can import and edit, or I can create my own. And then when it gets time to show those elevations, if I want a 2D elevation, then I can just align the hatch to the appropriate place in the wall and get the seams to line up, say, with the top of the door, for example. Right? So you can see how that seam there is lining up with the top of the door. I really want to leave some time for more questions, but just to recap, you can see where I've used a variety of tools here, walls and roofs, how they interact and clip each other, and how their components interact, along with some of the framing modules to put together this fairly detailed little structural and architectural model. You can see, for example, that even the floor is just this framed element that is composed of these same framing objects that comprise the roof, but just with no slope and defined as a floor joist rather than as a roof rafter, but it's the same type of object under the hood. So with that, I'd be happy to answer some questions.
All right then. So there's quite a few. So I will read them to you, and I'm trying to assign them to you so you can read them with me.
Okay, great. Yeah, we'll read them out loud, and that way other people can hear them.
Absolutely. Okay. In your roof components, is it possible to show your interior ceiling and an exterior soffit finish that are independent but on the same finish plane?
I can't do that with a roof component. So if I wanted to add an exterior soffit, I would need to show that as a separate object. In this case, I'm rendering it simply by, you're just seeing an extrusion, not an extrusion per se, but you're seeing the component for the structure here is just doubling as a kind of soffit. But if I wanted to be absolutely accurate, I would need to add a separate object there. Good catch.
Yes, indeed. How did you, or did you, directly use the SketchUp model for the kayak rack to create the geometry of your kayak rack?
I did. I took the model and then I put it in elevation view, and I traced the path with a polygon or a polyline, and then I assigned a circle as the profile, and I selected the two. And under model, there's an extrude along path command. And so when you have a path and a profile together, Vectorworks will create a path object. And then I just deleted the mesh of the rack object. The original SketchUp mesh, I just deleted it once I was done tracing it. For the motorcycle and the scooter, it's just too much work to bother tracing it. I just needed those quickly to kind of get the idea across, and then I can let those go. But because the rack might show up in multiple architectural views, I wanted to go through the exercise of redefining it.
Great. In the framing tool, what is a 2D model?
Well, yeah, 2D model is basically what we call drawings. They're just elevation views.
Okay. If the building is larger and has some structural posts, wood or steel, is it easy to add them into this 3D framing?
Yeah, absolutely. So there's a framing member which you tend to use for everything from rafters to beams to joists, but there's also a parametric column object. And so I use those in conjunction all the time. And so the column object can be used to represent either a structural column or an architectural wrapping around the structural column, or both. And the column can be wood or concrete or steel. And if it's steel, there's a whole library of steel profiles that you can choose from. So for example, it's very much like I can just take this framing object, And instead of choosing that to be a solid beam, I could call that a steel section. And I get this rather improbable sort of plywood beam, right? But I could get rid of the texture, give it a sort of a steely color, and then you can see that I have under steel sections I can select structural shapes, and I have a huge library of wide flanges or channels or Z-sections or angles to choose from, right? And then Vectorworks would just go ahead and model that for me, and then in plan view it just shows up as either a dashed line or a wide line or whatever. So just like I've got steel rafter members or beams, I also have steel columns.
Okay, so after creating your framing plans, if you cut section viewports through the wall, will you see the wall framing?
Yeah, only if I want to. So in this case, for example, I've got a section through this. I've got a section through this framing model, and you can see that it's actually cutting a section right through those framing objects. I don't bother having a section through my architectural model, but I could go ahead and show both the architectural wall and the framing wall. So if I set up my model correctly and have the correct class controls, I could, for example, in this framing section, turn on the architectural walls, but only turn on the exterior sheathing and not turn on the rest of the wall, like chipboard, for example. So if I set up the wall styles correctly and class them correctly, I have a tremendous amount of control.
Okay, Vectorworks automatically creates framing members of the roof when you use the roof framing, right? Is that correct?
Correct.
Okay, and this framing model is great, Licalisti says, but it is not live to the model. If you change the model, you'd have to recreate the framing model. Is that correct as well?
That's right. So the framing members are independent of both the walls and the roof object. So the roof object is just that they're not linked. So if I were to change the pitch of that roof, I would need to then update my model. And sometimes it's easier to just make a few edits to the framing model, but usually you would just trash the framing model and you would just, you saw how quickly it generated that that framing for you, and so you would just regenerate a new framing model from the new roof.
And also Lee says, wouldn't it be great if Vectorworks automatically created a parametric object for the studs?
Yes, it would. Yeah. Yep.
Okay.
You could use the column object as a parametric stud. Just have a bunch of really tiny little studs. I will say that you could probably create a parametric stud object using the new Marionette toolkit and graphical scripting language.
Okay. Can you quickly show us the process of aligning hatches? Is that quick, or could you do that?
The process of aligning hatches. I'm trying. There are a lot of different ways I could interpret that. So, for example, with this wall, you can see that there's a seam here, right? So let me do a hidden line rendering. Actually, let me cancel that and turn off that entourage class. See, it's when you said quickly that.
Yes.
Nothing's ever quick in a live demonstration. Always takes a long. Okay, so here's a hidden line rendering, and you can see that I've very cleverly laid out the seam to align with the window sill, right? But if I look at the render of that wall and look at the left side of the wall, you can see that I have a vertical offset that I've built into that wall. So if I wanted that seam to be, say, 3 feet higher, I would just add, say, 3 feet, and then you can see that it has now rendered to align with the top of the window rather than the sill of the window. So if that's what you mean by align, yeah, it's pretty quick. You just need to do it from the render tab. Sometimes it can be a bit of a trial and error process if you don't already know how much higher you want that seam to go.
And also there's another question about alignment. So I don't know if you already answered, but when aligning the hatch in elevation, is it just as an annotation or is it done in the model?
That's done in the model.
Okay.
Yeah, right now I'm in a model view, and that is if I'll change that, and then we'll go and look at the elevation. So there's if I go into this annotations on this model and I select everything and delete it, you can see that the seams aren't in the annotation, they're in the model.
Okay. Okay. Is the thermal insulation really cut out where the roof framing members are?
No. No, so if I were to do an energy analysis, what I would do is I would assign an R value to the roof based on the average of the weighted average of the insulation and the roof rafters.
Okay. For the floor framing, did you use the roof tool and zero slope?
I did not. For that, I just used a floor object.
Okay.
So you can see it's a floor object, and I'll delete it, and then some rafter members. And I used a floor object because that's a hybrid object, and so I could apply this plywood hatch to it so that in the plan view you could see this plywood hatch and we would know that that was intended to be a plywood floor.
Okay. Now, is it possible to model curved roofs and walls and get the framing model?
Ooh, the wall, if memory serves, the roof framer will handle very complex roof shapes. You can't really do a barrel roof per se, but if you had a segmented roof, the roof framer would handle that. I don't think the wall framer will frame curved walls.
Okay.
But it's been a while since I've tried. It may have been updated, but I'm not sure.
That's fair enough. Okay, now we have a longer question. I just assign it to you. And okay, as an architecture project grows larger and more complex with masses of varying heights and slope and flat roofs, do the adjacent volumes components continue to simply interact with each other, or do they become sticky as in Sketchup, complicating modifying the model as design alternates are explored?
They tend to interact well with each other. I will say that, you know, about the earlier question about changing the roof and changing the walls and having the framing model automatically update. The framing model is probably something that I would generate towards the very end of the design process after I had already made some architectural decisions. That said, once I framed the model, I made some changes to the window location based on the stud placement. So, so there can be a little bit of interaction. But so in other words, to answer that question, I wouldn't go ahead and do a framing model that was extremely detailed in schematic design unless it happened to be a single component. So for example, if I've done framing models of flat roofs in the past where it was really important to work out the structure of that flat roof early on in the design, because if it wasn't really structurally feasible within the budget, we were going to go in a completely different design direction. So just because you do a framing model of part of the project doesn't mean you have to do a framing model of the entire project. So hopefully that starts to answer that question.
Okay, one more question, and then I'm gonna let you go. Can you get complex? Can you get complex fascias in the roof and gutter components without modeling them separately?
There is a fascia accessory that can be applied to the roof face, or to the, I'm sorry, to the parametric roof object itself. If you wanted to have a very detailed, some sort of an Augie profile or something like that, you probably best to model that as just a square approximation in early design, and then in final design do an extrude along path to mimic that or to model that.
Okay, I have one more question if you have a few seconds.
Sure.
Why use a floor and not a slab?
I could have done it as a slab. I chose to do it as a floor because it was just quick and easy.
Okay.
If it was a concrete slab with perimeter and interior grade beams, I would have modeled it as a slab object and then subtracted out those voids.
Okay, fair enough. Wow, what a webinar packed with information. Your advice was good. You know, go back and watch the recording because I know a lot of you will, all of us will need it. By the way, I want to let everybody know that Francois will be you will be presenting a lecture at the Vectorworks Design Summit, right? Coming up on April.
I'm actually giving 2 talks.
Oh, pardon.
Well, I don't know if the other one has been publicized yet. I think it has.
Okay.
But yeah, I'll be at the Design Summit. So if you're going to be there, by all means, please.
Yeah, sure.
Let me.
Yeah. You can.
Find me and let's chat.
That's fantastic. It's the Vectorworks Design Summit is on April 25th, 26th, and 27th in Chicago. So great place to hang out. It's not too shabby. Okay.
Well worth the trip.
Yes, I will take the screen back, and I want to thank you all for attending this webinar. And I also want to remind everyone to visit our page at noveg.com, where you can find Vectorworks 2016 and the special promotion for first-time users. Please call Noveg at 866-362-8970 because the great deal, 25% off to new licenses. If you are not on Vectorworks Service Select yet, this is the time to take advantage of it. And also, don't forget that our next webinar is about collaborating in a BIM world with Bluebeam Review. And to rewatch today's webinar or previous ones, check out our Noveg YouTube and Vimeo channels. Our webinar playlist has webinars for every software taste, and today's recording will be posted in the next couple of hours. So spread the words and come back and, learn from Francois. Thank you so much for a fantastic presentation. By the way, great feedback throughout. And thank you for joining us, everybody. Bye-bye.
Thank you so much, Barbara. Bye-bye.
Bye-bye.